Good morning, Mr. Robinson.
Hey, good morning. How's it going?
Good. Good.
Okay, so a little late starting the day just because when I started up my laptop, it had an update to install, but I'll wait a couple minutes until I take attendance so that everybody has a chance to get in case people were looking for the invite and just bailed. Today we're going to start off with some updates regarding the AP test, and then I guess I'll just keep taking questions about the viral outbreak in case y'all want anything interpreted, do you? And then we'll get going today with section 9.2. Today we'll be talking about solving systems of 3 equations. And today we'll look at why elimination is such a nifty technique in terms of like what it can do for us bookkeeping. So for right now, think of any questions that you might have out there, and take a crack at solving this system of 2 equations. It's pretty straightforward. Use whatever technique you would like.
Hey, Mr. Robinson.
Good morning. How are your other classes going, everybody?
Pretty good, I guess.
Yeah.
Yeah. I guess we're just reviewing for APs now.
Yeah, I figure some of y'all saw that update. I'll explain what's going on for everybody who didn't after we get started. Yeah, I talked to Mr. Weeby about it yesterday because I drove to the Target in Pasadena to buy supplies, because the ones out in Pasadena are a lot more well-stocked than the one right by my house. And don't get me wrong, we stayed 2 meters apart the whole time. We were just like yelling at each other from opposite sides of his lawn. He also got a PlayStation because of how bored he's been. So I filled a bag full of PlayStation games that he hasn't played yet. I Lysoled all of them down and also threw that duffel bag to him across the lawn. It's a good time.
That's cool.
Okay, I'm gonna go ahead and assume that the people who are in now are the people who will be joining us for today. I'm gonna take attendance as such, and then we'll get going. And of course, I can't do 2 things at once. So give me 1 second to take attendance, and then I'll start talking about the AP tests. And then if y'all have any specific questions, I can answer those too, but it'll take me a second to do research because the individual information for each AP test is in a different PDF. And of course, I haven't memorized all that. The only one that I know off the top of my head is AP Physics. Okay, so we have everybody in except one. Is somebody signed on not with their name? There's one name in the chat that I don't recognize.
Mr. Robinson, that might be me. Let me leave and come back.
Okay. Nope, that's not. Oh, yeah, okay. Okay, we'll wait for Alex to log back in on his regular account and then we'll start. It sounds like a jet engine in my microphone, right? Do y'all hear the vents on my computer going crazy? No? I'm all alone, got it. Trying super hard to find an animated GIF I wanted to show y'all about the rate of the spread of the virus, but I can't, so I should have saved it to Google Drive when I saw it. If I find it, I'll show it to y'all later, or I'll post it straight to Google Classroom. Anyway, let's go ahead and get started now that everybody's had about 10 minutes to log in. Anyway, so did y'all see the updates to the AP tests? Did y'all happen to see that on the College Board homepage?
Yeah.
Yeah.
Okay, let me give a quick overview of it then for those of y'all who haven't heard yet, and then I'll answer what questions about it I can. Not everybody is capable of setting up like a little home studio like I have to continue lessons to the best of their ability. So some schools have just like straight up shut down without any sort of learn from home protocol. There's also some people who like can't do this because of the rules regarding privacy or whatever that public school districts have set up. So to accommodate for that fact that for some schools, things are just like cut off in March, the College Board is actually cutting the amount of content on each one of the AP tests to be limited to what should have been covered according to the standard AP pacing guide up through the first week of March. So if you Google College Board coronavirus, you'll find a long table in terms of which pieces of content will be covered for each AP test. It's usually excluding the last few units of the year that would have been covered in late March and early April before the AP test. On top of that, instead of just offering one regular test date for the AP test, they're going to offer two. So if you want to take the test while the information is still like fresh in your mind, there will be an early test date and a late test date. Those test dates will all be announced on April 3rd. Past that, the form of the tests will all be altered compared to what they're supposed to be. Almost all AP tests are half multiple choice, half free response, each one taking 90 minutes for a grand total of a 3-hour test. For the AP test for this year and this year only, the AP test will be 45 minutes and it will be free response only so that they have a chance at controlling cheating or whatever might happen. And all of the tests before they're graded by hand will be passed through a plagiarism checker. Are there any questions about changes to the AP test Yes, no.
So, like, would it be online?
Yeah, they will all be online. There will not be tests at testing centers. You will be able to do the AP test on whatever devices you have at home.
Oh, okay.
Yeah.
Yeah.
I would definitely go on to the College Board's website regarding the AP tests. Look at which units have been removed and then compare that to the pacing guides for all of the AP tests that you guys have, so that you can know which parts have been removed. Like in the case of my AP Physics class, it makes it so that the chapter that we're on now is actually the last chapter that's on the test. So instead of having 2 more chapters after this, we're just going to wrap up, start reviewing, and then after the AP test, I will cover the rest of the content for the seniors just so that, they see it before they go to college next year.
Miss Robinson,
Mm-hmm.
so since it's going to be at home, does that mean that we're going to be out till after the AP tests? Like we're going to be home, most likely, till after?
Oh, and I guess this gets to more general questions just about the viral outbreak. So while our school has no official protocol, we have not yet announced an official protocol that we will be out after spring break. I cannot imagine a sequence of events that would allow us to reopen.
Right. Okay.
It just doesn't seem reasonable at this point. I actually think no schools will open before the start of next school year. And even then, I think the start of next school year may still be affected depending on where the viral outbreak is at by midsummer. I wouldn't expect things to get back to anything that resembles normal until late fall, early winter, and that's at the earliest.
Mr. Robinson, first of all, sorry I got disconnected. I had an internet spike.
No, that's cool. It happens. Like as we speak, every person in the country is logging on to a Zoom meeting instead of going to a physical place. So just expect the internet and expect Zoom to be unstable, which is part of why I'm backing all this up to YouTube. Anyway, what's the question?
Oh, yeah, I was also gonna ask, don't you think people are kind of overreacting, like the
No.
media and stuff?
No,
Because
absolutely not.
it just,
No.
I feel like there's something behind it. It's just so unnecessarily crazy.
And
someone in the government wanted to put a stop on the economy for 2 months or something for some time.
I mean, conspiracy theories are fun, but they're not useful. I mean, I guess you can choose to believe that the experience of doctors in hospitals all around the world is fake, but the reality of the situation is that we're already in the hundreds of deaths. The rate of death is known in terms of how many people who are infected will be killed. And the reason why we have all been sent home is due to the fact that we actually have a very, very fragile healthcare infrastructure, not just in the United States, but worldwide. And the moment that ICUs are saturated, which they're already getting to that point, just because most hospitals only have a couple dozen ICU beds, the moment that those are saturated and respirators are all in use, people who need respirators to survive will simply be let out based on triage rules, and they'll die without medical treatment. It is so dire that in Washington, they're building a hospital in a soccer field simply because they know that they are going to need more beds. And one of my classes is taught by a professor who works at JPL, and all of JPL is switching their on-site infrastructure, because if you don't know, JPL produces things on-site. They have small factories and 3D printer setups. They are currently making ventilators, because we all know that once the thing about math is that you can use it to chart out what is going to happen over the next few weeks. And we know that there will come a time in the very near future, within a week or two, where all of the ventilators in the United States are in use, and that people who need ventilators won't be able to get them, which is why JPL is switching over all of their manufacturing capacity to producing ventilators to help deal with the crisis. No, we are living in a global emergency, And people not talking about it that way are either conspiracy mongering or being irresponsible. And even if we do respond with the most severe things that we can do, travel shutdowns, switching over to emergency production of goods, the infection rate and what it will require for us to respond, we still won't be able to respond adequately. We are still going to fall short, even with everything we are doing and putting in place right now.
I see.
I mean,
That makes sense.
we're on track, not just for we're on track for 7 or 8 figures of infection. That is to say millions or 10 millions of people infected, potentially higher because we don't know what the current spread is in the United States, which puts us on track for 6 figures or potentially 7 figures dead.
But
Mr. Robinson? Oh, does someone else have a question?
Go ahead.
Hey, Mr. Robinson, what do you think of the idea of China paying reparations for this?
What? Why? Why would they?
Reparations.
And how could you possibly enforce that on them?
I don't know. I'm just saying, isn't there like a possibility of that? I don't know how they would do it.
No. What did they do? They didn't create the virus.
Didn't they know for a few months before they released it to the World Health Organization?
I mean, they could.
I mean, obviously, it's not their fault, the outbreak. What control do they have? But the way they responded to it, that's what I'm trying to say.
I would argue, okay, so they have a very opaque government. So whether or not there was a active cover-up of the issues, which like they wouldn't be the only ones guilty of that. Every single government attempting to maintain some semblance of peace and order during the initial spread of the outbreak, because there's all sorts of incentives to do that, right? Like to tamp down panic, to protect the stock market long enough for politicians to pull their own money out while everybody else gets screwed. There are a ton of incentives why a government would be slow to respond publicly, but any sort of like shifting of blame from one country to China is just a political game. Like, sure, they responded slow and irresponsibly. We also responded slow and irresponsibly. So they may be responsible in some sense for the spread of it within their own country, but we're responsible for the spread of it within our own country, and we're on pace to have the worst infection rate out of all of the countries who have experienced it. We surpassed the rate at which it was growing in our country over Italy 2 days ago. So reparation? No, that's crazy. That would never happen.
Wasn't it declared like a national emergency a weekend though?
No. All of the actions that are going to do anything so far have all been bottom up. They've all been states closing themselves one at a time, school districts closing themselves one at a time, people choosing to switch into an emergency response mode or emergency supply production. Top down, no. Are there any other questions about the AP tests?
Mr. Robinson, are they all 45 minutes? I know like that.
Yeah, they've all been reduced to 45 minutes worth of free response.
Jesus, okay.
Yeah, and it's not available yet, but the College Board website said that they would make online resources available. So I assume that means that they are preparing samples of what these 45-minute free response tests will look like so that we can start preparing you for and training you for that type of exam. So as soon as that stuff is available, I will let you know in case your own AP teachers like don't notice or whatever. But I am immediately switching over the way that I like do my AP physics class so that we can all get ready for the free response. Though I gotta admit, I'm pretty bummed that, I don't know, we spent the whole year training to get good at the multiple choice, and I finally got my class good to that point, and now, you know, they won't ever need to use that skill.
Yeah.
Mr. Robinson?
Yep.
Is the AP test that's like being given on the earlier date the same as the one that's being given on the later date? Or are they
I
two
s-
different ones?
I'm going to assume that they would have to be two different ones so that nobody who takes the early test date can share what the questions are to those taking the late test date. So I figure they're just going to be completely different. Yeah. That's a good question. Yeah. And
But
I don't know, like which one you take, I believe will end up being up to you. If I was you, I would just take the early one. Like if
Yeah.
you've already covered the content, just take it so that you don't have to review all that stuff like a month from now. Are
Chris,
there
you
any
want to take the
other?
early one?
yeah, hell yeah. While it's still fresh in my mind.
You know, honestly, it'll depend on the
Jamestown
person
and
and it'll
Roanoke is
depend
fresh
class
in
by
your mind?
class, but that's exactly why they're offering 2 test dates. So that if you are cool with the content and you don't want to do a comprehensive review in late April, you can knock it out early. Or if you're behind, then you can spend the month to cram and then get ready for the late test. But that's why they're offering 2. Because they know that lots of different people are in lots of different situations during this crisis.
Hey, Mr. Robinson,
Uh-huh.
our U.S. history one was cut from like eras 1 to 7, which ends it at about 1900. So you think it's probably going to be about Civil War?
Alex, ends at 1945, ours.
Yeah,
Seven.
it's until
Oh, yeah,
era
yeah.
7.
Oh yeah.
Yeah, so that ends with World War II. So it
45.
could be anything up through there, or it's funny that they cut it that way because that's always how they feel like. That's always how I feel like they cut high school history anyway. It always feels like it ends with World War II because everything that's happened since then isn't discussed in any serious way. High school history is
What about the
very,
Cold War?
yeah, high school history is very sketchy about covering Vietnam
Cool, yeah.
or
Yeah,
the
yeah,
other
yeah.
failures of the Cold War, or about all the stuff we did in the Middle East in the 1980s, because most of the history post that is
Shameful.
painful to discuss with high school kids. But yeah, all the AP tests, if you go on and Google College Board coronavirus, you can see where the content's been cut. Hey, anyway, that's a fun discussion. Let's go ahead and start by solving item number 2, and then we'll get into notes for today. And I'll probably be cropping this discussion significantly before I get it on YouTube, just because we're not actually starting until like 20 minutes in. Let's go ahead and solve this by elimination. And so if we want to solve this system over here by elimination, what do we multiply by?
3.
Yeah, let's go ahead and take the top equation and multiply it by 3 so that we can line up this negative 3y with this positive 3y and get some elimination going. So this top equation will become 9x minus 3y is equal to 21. The bottom equation remains the same. That's just 2x plus 3y is equal to 1. And now to do the elimination, since I have these lined up as being equal and opposite, all I have to do is add them. And that's going to give me 11x is equal to 22. 3y minus 3y adds up to 0. And so x is equal to 2. And then I can go back and I can plug 2 into either one of the top equations in order to solve for y. I'm going to use the first one just because this y is already isolated. So this gives me 3 times 2 minus y is equal to 7. And so it's going to be 6 minus y is equal to 7. Minus y is equal to 1 if I subtract 6 from both sides. And so that gives me that y is equal to negative 1. And keep in mind that when it comes to these solutions, this represents a point in space. So we'll have to write this as an ordered pair, 2 comma negative 1. Are there any questions on this item of the warm-up? No? We'll take that as a widespread no. Okay, so today we're going to get into notes. Today we're going to move on to the second section in chapter 9. Today we'll be talking about section 9.2, linear systems of 3 variables. Okay. So just a quick recap of some basic ideas that we need to have control of for this section to make sense. Number one, when it comes to talking about sets of 3 variables, instead of just talking about x and y, which are flat on the xy plane, systems of 3 variables discuss what's going on in 3D space. So like the type of space that you're in right now, which is to say not only can we go left and right, not only can we go up and down, because those are our like traditional conceptions of x and y, but there is also now a third dimension z, which goes in and out of the paper, which is hard to imagine. So just keep in mind that these types of systems describe what's going on in 3D space. So instead of having x and y flat on the paper, I have x and I have y, and z would go up away from this so that we have 3 dimensions, all of which are perpendicular to each other. On top of that idea, right, the fact that these are describing things in 3D space, we also have to think about the fundamental theorem of algebra. Does anybody remember the fundamental theorem of algebra? I'll give y'all the if part of it. So the fundamental theorem of algebra says that if the number of equations,
that they all have to be equal, right?
if the number of equations equals the number of variables, then what? In the last section, how many variables did we have?
2.
2.
And how many elements did our solution have?
2.
2. We had an x and a y. What the fundamental theorem of algebra says is that if the number of equations equals the number of variables, then a solution exists. It doesn't matter how many variables you have. You could have some sort of problem with 46 variables in it. So long as you can produce 46 unique equations and feed them to some kind of computer, that computer can locate the 46 value set that solves that system of equations, assuming one exists. This is to say that in this section, we'll be solving for an ordered set in 3D space, some combination of x and y and z, something that represents, a floating point here in space at the intersection of these 3 values. And if I want a 3-value solution, right, how many equations do I need?
3.
Yep. So we'll be looking at how we play around with 3 values that give us, 3 values based on 3 equations. Now, the first thing is that when it comes to linear equations in 2D space, right, we always have a line. We have a line with a slope and an intercept, and we solve for the intersection of 2 lines. However, when it comes to linear equations of 3 variables, linear equations of 3 variables represents a plane. And if you think back to last section, we had some different cases where, depending on the physical orientation of our lines in 3D space, we could have different solution sets or certain non-solution sets. So that is to say, if I have line 1, line 2, if they cross in space, I have a solution which is a simple x comma y, right? If I have 2 lines which are parallel, then there is no solution to that set of systems, because when we're solving for a solution, we're looking for where these 2 lines cross. Or I could have an infinite number of solutions if those 2 lines happen to secretly describe the same line. Then technically the answer to the question, hey, where do those 2 lines cross? The answer is, well, everywhere that those lines exist, right? So we have 3 different outcomes based on our potential orientation of those lines. When it comes to these equations in 3D space, we have more possibilities than that. And so instead of drawing something poorly on the thing, I got a slide ready for this part of the lesson. Let me go ahead and switch my screen share over to that. Okay. So here's what we're looking at when it comes to systems of 3 equations. There are 2 different ways that we can get a solution. So in each one of these, right, these planes, the green plane, blue plane, red plane, would be a 3-dimensional linear equation. And so we can get problems where the answer is a straight up X, Y, Z ordered set. That is to say that those three planes all intersect at a unique point in space. There are other cases where we'll do elimination, and despite our best attempts, we won't be able to eliminate it down to an ordered set, but instead we'll get a line. That is to say that all three of our planes in space line up, but they do not meet at a unique point. Instead, they meet up along a line, and so our solution would have an infinite number of points, but all of those points would be bound along one specific line. We also have cases where if two of the planes are parallel, or if all three of the, if two of the planes are parallel, or if all three of the planes are parallel, they do not intersect. Or we could have other cases where the planes all intersect, but not all three of them intersect along the same line or at the same point. And as such, they lack a common point of intersection. So there are a lot of different ways that we can get no solution. Not just if one set is parallel, there's a bunch of different orientations that can lead to no solution. Is this first part okay in terms of what these systems are describing?
Yeah.
Okay. So let me go ahead and talk about what we are looking at and kind of what your general approach is to finding a solution the easiest way possible. When it comes to these systems, the way in which you'll most commonly see them written is in standard form. You definitely want to write three-dimensional equations in standard form just because there's no correlative slope intercept form. And that is to say that my linear systems would be of the form AX plus BY plus CZ is equal to D. So this is what one linear equation looks like in three variables. However, like I said, to solve this, we are going to need three equations that are all of this form. So we have EX plus FY plus GZ is equal to H, and then I, J, K, L, X, Y, Z. And this is what problems of this form will look like. And keep in mind, each one of these represents a plane in 3D space. And we're trying to see where, if anywhere, all three of these planes cross each other. So the general procedure that you want to take to this is you want to start off by using, and of course, you know, technically, since this is math, you could start this out any way you want. And as long as you eliminate away all the variables and get an answer, you'll be good to go. But I want to offer y'all a more of a recipe. We want to start off, so step number one, use A to eliminate E and I. So start off by using one of the X values to eliminate the other two X values. Why might this be a good strategy? What happens?
Because then you're only left with two.
Yeah.
Because then we're only left with
function.
Exactly. So this is a linear function no matter what. And the thing that makes it a linear function is the fact that there are no exponents here other than 1. And all of these constants are just being multiplied, and there's no weird mixed up variables. But the reason why we would want to start off by using one of these X values to eliminate these other two X values is that then it leaves us a problem that we know how to deal with. Then it leaves us a regular old two-variable, two-equation problem, which we can solve using whatever technique we like. This part down here will give us back Y and Z. And then once you have Y and Z, just take those two values and plug them back into any of the other equations in order to solve for X. So after we use A to eliminate E and I, then we solve for Y and Z by normal methods. And then step 3, we back substitute to get X. Is this okay? Yes,
Mr.
no.
Robinson, what does number 3 say?
Back substitute for x.
Okay, thank you.
Yeah, so once you have y and z by your normal procedure, you take it, plug it back into any of the 3 original equations, and that will give you the x coordinate. So let's go ahead and do an example, and then that will probably take us to the end of the period. Tomorrow, once we start up, we'll get going a little bit quicker because I'm sure we won't have, as many questions since I won't have another update, I don't think. And then we'll spend the rest of the day tomorrow working on the homework. And of course, the point of doing it on Zoom is so that y'all can chime in, ask questions, and get those questions answered on stream. Item number 1, let's say that we have the following system. For example, I have x minus 2y plus 3z is equal to 9. I also have negative x plus 3y minus z is equal to negative 6. And then I also have 2x minus 5y plus 5z is equal to 17. And as we go along, because I was doing this in the last section just so that we would be used to it, I'm going to label these equations, and I'm going to keep those labels the same as we move along in case y'all get lost and lose track of exactly which equation it is that I'm manipulating. So I'm just going to give these Roman numeral names: equation 1, equation 2, equation 3. So like I said, the first thing that we want to do is we want to try and eliminate 2 of the x values here so that instead of playing with 3 variables and 3 equations, we can reduce this down to a 2-variable, 2-equation problem that should then be solvable. Now notice if I take equation 1 and I add it to equation 2, that will eliminate x. And then if I take equation 1, how can I eliminate it with equation 2?
Multiplied by negative 2.
I could take equation 1 and I could multiply it by negative 2 and eliminate that with equation 3, and then that will also get rid of the x. So here's what I'm going to do. The first thing I'm going to say is I'm going to produce a new equation, which is equation 1 plus equation 2. And this is more like math theory stuff, but whenever you have a set of linear equations, any linear combination of that set of linear equations, that is to say that any of these linear equations, you can take them and you can multiply them by a constant. You can also take them and add or subtract them together, and those operations will not change the answer to the problem at all. Nonetheless, if I take equation 1 and I add it with equation 2, here's what we're going to get. The x's eliminate. That's good. That was the point. Yeah. And then it's going to be negative 2y plus 3y. So this is just going to give me positive y. 3z minus z is going to give me plus 2z. And then 9 minus 6 is going to give me 3. So there is one 2-variable equation produced by adding equation 1 and 2. Now the little bit of side work that I'm going to do is, because what did we say we had to do to equation 1 before we eliminated it against equation 3?
Multiply by negative 2.
I'm got to multiply it by negative 2. So I'm going to take equation 1 here and I'm going to say negative 2 times equation 1 is actually equal to negative 2x plus 4y minus 6z is equal to negative 18. All I did there was I went across and I multiplied all of the terms in equation 1 by negative 2. And now to produce my second equation, this is going to be negative 2 times equation 1, then plus equation 3. And so if I take this and I add it here, again, it's going to delete the x part. So it's going to be negative 2 plus positive 2 for 0. 4y minus 5y for negative y. Negative 6z plus 5z for negative z. And this is going to be equal to negative 18 plus 17, which is negative 1. Are there any questions there? Is that okay? So notice in these first 2 steps, by combining these equations, I have eliminated x completely. And now I can solve for y and z. And then once I have those, we can go back to the original equation and solve for x. What's the next variable I should eliminate? What's smart?
Y.
Yeah, I can eliminate y just by adding these 2 equations together. And so if I take these 2 equations and I add them together, I'm I'm going to get that y plus negative y is 0. Negative 2z plus negative z is just z. And then 3 minus 1 is just 2. So there's the first element in my set. I know that at this intersection, z must be 2. Is this first part okay?
Yep.
Okay. Now I can get y by taking this and plugging it into literally any of the equations here, assuming that I've made no mistakes so far. So I'm going to take it and I'm just going to plug it into this equation because y is already isolated. So if I take z is equal to 2 and pop it in there, I'm going to get that y plus 2 times 2 is equal to 3. And so y plus 4 is equal to 3. I'm going to subtract 4 from both sides. Y is equal to negative 1. And there's the second element in my set. And now finally, I can take these two values and plug them into any of the initial equations whatsoever. Again, I'm just going to plug this into equation number 1 because x is already isolated, right? So I just got to pop in the y, the z, that'll give me back my x. And so that first equation is telling me that x minus 2 times negative 1 plus 3 times 2 is equal to 9. X plus 2 plus 6 is equal to 9. And so I'll subtract 8 from both sides. X is equal to 1. And so just like before, remember that this is talking about a point in physical space. This is to say that these three coordinates represent a position. And as such, the best form of the answer is to write it as an ordered set. 1, comma, negative 1, comma, 2. This is to say that if I graphed my three original equations, so let's say that this is plane number 1, this is some kind of red plane. Plane number 2, some kind of blue plane. And then plane number 3, some kind of green plane. These three planes all represent some unique point in physical space. And this point would be right here in this case, where all three of them intersect. So I have the red plane, the blue plane cuts it, and the green plane cuts it. And you can see how they would all intersect right there. It's saying that this point is 1, comma, negative 1, comma, 2. It is the only point in 3D space which satisfies all three equations simultaneously. Are there any questions on solving systems of 3 equations in 3 variables?
Mr. Robinson, I'm kind of confused on how we got rid of an entire equation by eliminating x. So what can we like go over what we did to get rid of x and just have those two equations?
Yeah, so we're not getting rid of equation 1. It's just that once we eliminate variable x, it stops being relevant. So like I said, the fundamental theorem of algebra tells us that so long as the number of variables is equal to the number of equations, some sort of solution can be solved for. So the first thing I'm doing is I'm hitting equation 1 against equations 2 and 3 in order to eliminate x. It was set up so that I could instantly do that here. So 1 plus 2 gives us one equation with no x. And then to destroy this x value down here, I had to multiply row 1 by negative 2. So this equation is just row 1 times negative 2. But then when I hit this against equation 3, notice it's negative 2 times equation 1 plus equation 3. And while y'all are getting used to this, I recommend that y'all keep some sort of similar bookkeeping system, just because it's really easy to get to this point and be like, hey, what did I do that produced that equation, right? I hit negative 2 times equation 1 against equation 3. That just gives me this, negative y minus z is equal to negative 1. And now I am looking at a smaller subsystem that exists within this larger system. This is now 2 variables, 2 equations. And so we go from a 9.2 question to a 9.1 question. Solve that, and then you can use that information to get the third missing variable.
Okay. So pretty much, could you say that you're setting x, for all 3 equations, you're setting x like as equal, you're isolating x. So you're pretty much equaling x for each equation.
Yes, you are starting by making sure that the x values can all be eliminated against each other.
Okay, oh yeah, okay.
And then once you eliminate those x values, that gives you y and z. And once you have values for y and z, you can go backwards and solve for x.
Okay, got it.
Mr. Robinson,
Yep.
you know how you wrote the coordinates in the X, Y, Z like order?
Yep.
Do you always have to do that?
Yeah, the order is crucial. The order of the numbers is the same as the order of the letters.
All right.
Mm-hmm. Any other questions out there?
Mr. Robinson,
Mm-hmm.
could you use substitution by moving x to the other side and bringing 9 to x's side?
You could use substitution to do this. However, I strongly recommend against it because of what a nightmare it is in terms of bookkeeping. What you would have to do in order to solve this system by substitution is, in the first step, you would have to solve one of these equations for x. You would have to solve the second equation for y. You'd have to take this solution for x, plug it in here. You'd have to take this solution for y, plug it in here, and then that would allow you to solve for z. While substitution does work, I strongly recommend against it for any system that is larger than 3 variables. Substitution is a method that you only want to use for nonlinear systems. We're going to see after spring break that when it comes to matrices, which, like, I could take this, I could rewrite it as a matrix, that all of those matrix operations are based on elimination. I expect y'all to use elimination for this entire homework assignment because of where we go this chapter.
Okay.
Are there any other questions out there before I end the stream and post the homework?
Don't think so.
No? Okay. Anyway, y'all have a nice day, and as I will constantly recommend y'all, check out those free exercise apps that I talked about. Like I said, Down Dog is free until summer in case you want to get buff doing yoga. Find something to stay physically active and get used to it, because we're all indoors until the fall. I'll see y'all tomorrow morning. Y'all have a very nice day.
See you,
Mr.
Mr. Robinson.
Robinson.